What about if we take this whole idea of completing the square and apply it to a quadratic without numbers? In other words, let's try to develop a general formula for completing the square, one that would apply to any quadratic, a plug-and-play kind of thing. If we take the general form of the quadratic equation without numbers, except for 0, and use completing the square to solve for x, then the quadratic formula is born. Step 1. Divide whole equation by a to reduce the leading coefficient to 1. Step 2. Move c over a to the right-hand side of the equation, leaving an empty space where c over a was. Step 3. Take 1/2 of the middle term, b over a, and square it. Complete the trinomial square with this expression by placing it into the empty space. 1/2 of b over a is b over 2a, and b over 2a squared is b squared over 4a squared. Because b squared over 4a squared was added to the left-hand side, then b squared over 4a squared must be added to the right-hand side. Step 4. Factor the left-hand side of the equation as a perfect trinomial square and add the right-hand side. Notice that the left-hand side of the equation was factored following the rules. First term, square root of x squared is x. Last term, square root of b squared is b, and the square root of 4a squared is 2a. Also, the middle term matches the addition of the multiplications of the inside and outside terms. Twice x times b over 2a equals bx over a. Now, the addition of the right-hand side is a typical addition of fractions. The common denominator of a and 4a squared is 4a squared. The actual addition is shown here. Now to step 5. Find the square root of both sides. Because here we have two of the same binomial, the square root of the left-hand side is one of the binomials. On the right-hand side, the numerator negative 4ac plus b squared cannot be simplified because the two terms are tied up with addition. So they have to stay under the radical. Notice here that every square root has a positive and negative value, and the radical sign must start with plus or minus. Next, the denominator of the right-hand side has been simplified. The square root of 4 is 2, and the square root of a squared is a. Notice also that the expression under the radical has been switched and now start with b squared. This doesn't affect the value, but the expression looks better. Step 6. Solve for x by subtracting b over 2a from both sides. Because both expressions on the right-hand side of the equation have the same denominator, place both numerators over the same denominator. This is the formula for quadratic roots. X is equal to negative b plus or minus the square root of b squared minus 4ac, the whole thing divided by 2a, where a is the leading coefficient, the quadratic term. B is the coefficient of the middle or linear term, and c is the last or constant number. And what do the roots mean? In section 8.1, the shape of the quadratic line was given as a parabolic curve crossing the x-axis. When the curve crosses the x-axis twice, you get two distinct roots. When the curve does not cross but just touches the x-axis, one double equal root is formed. Now, when the curve does not cross the x-axis, you will not get any real roots. Depending on the values of a, b, and c, the shape and position of the curve is determined. This is an example for two distinct roots. A equals 2. B equals 5. C equals negative 1. Substituting the values in the quadratic formula and using a single TI-35X calculator, 5 squared is 25. Negative 4 times 2 is negative 8. Times negative 1 is positive 8. 8 plus 25 is 33. The square root of 33 is 5.745. A is equal to 2. So the denominator is 2 times 2 or 4. Two values of x. Negative 5 plus 5.745 divided by 4 or 0.186. And negative 5 minus 5.745 divided by 4 or negative 2.686. This is an example for one double equal root. A equals 1. B equals negative 5. C equals 6.25. Substituting the values in the quadratic formula and using the same calculator, x equals 2.5. This is an example without roots. Solve. A equals 1. B equals 2. C equals 6. Substituting the values in the quadratic formula and using the same calculator, stop. The radical is negative and cannot be solved without Algebra 2 knowledge. Because the square root of a negative number cannot be determined, the answer is not real.
Okay, so you ask yourself, is there a way of knowing if the quadratic root would be real? Let's see.
You see this part of the equation that has the radical? Well, this part of the quadratic formula is called the discriminant. And the discriminant allows us to peek into the formula to see if the quadratic has any valid roots. If the discriminant is negative, no need to continue. If it is positive or 0, continue. For example, A equals 7. B equals negative 13. C equals 13. Using the discriminant. 169 minus 4 times 7 times 13. 4 times 7 times 13 equals 364. 169 minus 364 yields a negative answer. If the radical is negative, no real roots.